Gentlemen, welcome to the Gordon Card Science and Technology Center here at the Museum of Science. My name is Eric, and today we have a very special guest. Please join me in welcoming Cindy Fitzgibbon from WCVB Channel.
Hi, everybody. I'm so glad all of you are here. I didn't know how many people would wander over, so is everybody having a nice time today at the museum? Yes! That's great to hear. I'm so happy to be here. I'm a meteorologist on Channel 5, where I've been for just over 3 years, but before that, I was locally in the market as well, at Fox for more than 10 years. So I've been doing this for a while, and we're going to talk a little bit more about forecasting today and the science that is meteorology with Eric.
All right, so we've got some short video clips from the team's weather school video. They're just going to talk a little bit about how to forecast the weather, and then we'll talk a little bit about the really details of how the science and the technology of that really works. So our first video is with one of your colleagues, Danielle.
Forecasting the weather is a science, the science of meteorology. Harvey, Mike, Cindy, and I all went to school to study this science, and we all have degrees in it. It's not just a job, it's something you love to do. I've wanted to do this since I was in the 6th grade.
Wow, 6th grade, that's pretty early.
That is true. How many of you out there are not even in 6th grade yet? All right. Any 6th graders out there? No. Well, yes, you won. Excellent. Well, when I was in 6th grade, kind of a light bulb went off for me because one of the meteorologists where I grew up, and I grew up in Maine, near Portland, came to my classroom, and he basically said that his job was to study the weather and talk about it. And I went, huh, I love the weather. I was obsessed with the weather when I was younger. I just looked at the sky and I wondered why there were clouds there, and then where they were going and where they came from, and why they were moving this way one day and that way another day. And every time it snowed, and it snows a lot in Maine, I would go outside and I would measure it. I had a spiral notebook with measurements, and I would call all my friends because we didn't have texting back then. And I'd tell them how much snow we got, and they didn't really care. But I was obsessed with the weather, but I was extremely shy when I was younger. So for me, talking in front of people was something I never, ever, ever thought I would do to a group this size or to a lot more people on television every day. So as I got older, I kind of grew out of my shyness. My personality changed, but my interest in the weather did not. So I went to school, and I got a degree in meteorology in the year 1995. So I've been doing this since then. So what I studied in school really had nothing to do with television. I studied a lot of math and science. I took a lot of physics and calculus and theory to learn and understand how the atmosphere works. So now what I do every single day is try to answer the same exact question, and that question is, what is the weather going to do today and the next 7 days now into the future? So yeah, for me, this has been something that I've been interested in for a really long time. And all of you here today, I'm guessing, are somehow interested in science. So as you walk around the museum, I'm guessing that there are certain things that interest you more than others. Just keep in mind that whatever interests you now, as you get older, if that interest is something that's a passion for you, you can pursue that, and your career may be actually doing something that you love to do. So for me, it was weather. For you, it might be something else. But whatever it is, you can get up every day, and your job can be doing something that you're really interested in. And it's a good thing I like doing the weather, because you know what time I get up every morning? I get up at 1:45. Yeah, so it's a good thing I like doing it, right?
So you probably have to get up that early, because you're not just talking about it, you're actually doing the science, trying to figure it out. So our next video talks about where the forecast starts.
Yeah.
So this is where it all begins, right here in the Storm Team 5 Weather Center. See these computers? Well, we look at them all day long. Without them, weather forecasting as we know it today would not be possible.
Now, these aren't ordinary computers like you might use at home or school. They're getting data from a satellite dish outside the studio. 24 hours a day, 7 days a week, 365 days a year. Everything from temperatures to wind speed and direction to satellite and radar images from all over the information to see what is going on right now. This is called an observation. We also look at pictures taken from space to show us where the clouds are. Here we've just taken a bunch of these pictures and put them together into a series called a satellite loop. And radars can show us where the snow and rain are falling from those clouds. We take those images and make them into a movie we call a radar loop. Here at WCVB Channel 5, we have our very own radar that's based on hockey disc. It's scanning the skies every minute of every day, ready to track storms to help us keep you safe.
So really, if you want to know what the weather is going to do, you have to know what it's doing now, and you have to know really precisely. So all those observations go into it, right?
Absolutely. So Channel 5 is located in Needham, where there's currently a bunch of construction going on 128, so it's good that we're not there today. So our forecast area that we forecast for goes beyond Worcester out in toward western Massachusetts. It goes up into southern New Hampshire. It goes, into Boston, obviously, and all the way down to Cape Cod. So the weather can change pretty dramatically, as I'm sure you know, between all of those places. The weather can be very different on the Cape. At the same time, it's different in Boston, and at the same time, it's different in Worcester. So we basically take observations of what's happening right now, and in order to do that, we have a lot of different tools, which you saw, the satellite images, the radar images. Most of what we do is done at a computer. We are just ingesting information and analyzing information to know what's happening right now before we can even begin to figure out what's going to happen in the future. And if we do not have a good handle on what's happening right now, if you think about it, what's the domino effect? If you have bad information to start, and then you try to extrapolate that into the future, it's also going to be bad. So it's very important to get accurate information initially before you can take that out into the future. Do you remember Matthew, the hurricane, like a month or so ago? The National Weather Service, NOAA, was sending extra aircraft into that, extra balloon launches, which we'll talk about, but it was all in an effort to get more information on what the storm was doing right now, so that information could better go into help forecast what it was going to do in the future. And even with all the technology and all the information, I'm not sure if you recall, but the hurricane intensified much more dramatically and faster and became much more intense than it was ever forecast to do. And that is one of the big challenges that meteorology struggles with. Not so much in where a storm is going to go, but that rapid intensification. That is something that is being targeted right now by a new satellite that's being launched this month in November called GOES-R. That's one of the things that it's actually going to be helping to improve. But yeah, so much of what we do is making observations of the current state of the atmosphere. How long have you guys been here? An hour or two? Did anybody just come in? Who can tell me what the weather was like when you came in the building? What was the weather like? Yes. Cold. So you just described the temperature. Yes. What else? What's another observation about the weather? Yes. Cloudy, so you noted the sky condition. I bet you if you went out there right now, it will look completely different than it did when you came in. The clouds won't be in the same place, because they're always moving, right? But the weather, we're taking a snapshot of the atmosphere at a particular time, at a particular pace, at that exact moment. So the temperature, the sky condition, what else? What else was the weather like when you came inside? Were you blowing around? Was it windy? Right? All those different things, they're always changing. Yes, what else was it like?
When I woke up, I saw that the moon surrounded by dark clouds.
You saw what?
The moon surrounded by dark clouds.
Oh, the moon. You got up early. Sorry, Mom and Dad. The moon was surrounded by dark clouds. Yeah, so it's great to notice all these things and pay attention to what the weather is like right now, because they're all clues and important to figure out what the weather's going to do in the future. Right. So all these observations. Obviously, we can't know because we're not in every single place we're making forecasts for, so we rely very much on technology and equipment and different tools to help us gather all that information about the current state of the atmosphere before we can forecast what the atmosphere is going to do in the future.
So one of the things we're familiar with in the forecast are these big maps with the colors. You can see it moving across, and that's the technology. We're talking about the radar. So what actually is it measuring? Can you see the rain with the radar?
Yeah, so absolutely. So this particular radar image is showing a pretty intense storm moving through the North Shore right now, and you see there's the color green. That is indicating reflectivity. The radar is looking where something is falling from the sky. Now, when the skies are clear and the radar is in clear air mode, sometimes things show up on the radar. What could be moving through the sky? Birds, smoke, things like that. But in this particular instance, that is showing us where there's actually precipitation, rain falling from the clouds, and the different colors indicate different intensity of the rain falling. So as the colors change, they go from light green to dark green to yellow to orange to red. That is indicating heavier returns on the radar, more intense precipitation, more intense rain. And I'm guessing there was lightning with this storm. That red box it means it's a warm storm. It was pretty intense as it was moving on through. So this is just reflectivity mode. Our radar, we have our own that's based out of Hopkinton, and we also have access on our computers to the government radar from the National Weather Service, which is based out of Taunton. We can look at more things than just reflectivity. We can look at the motion of the returns, which way the cells are moving. Because that's very important. Has anybody here heard the term Doppler radar? Doppler radar? That was actually named after a gentleman called Christian Doppler, who was paying attention. Okay, and this is going to be a relationship between something that's not meteorology and something that shows you someone who was observant. Because have you ever noticed if you listen to a train, when it's coming towards you, it actually sounds different than when it's moving away from you? He paid attention and he said, huh, and he observed that. And that theory of things sounding different as they're moving toward and away from you is the theory behind Doppler radar, because Doppler radar allows us to see if something is moving toward or away, and that's really important in severe weather and thunderstorms when we're looking for rotation. Okay? So sometimes if there's a tornado warning or something happening and you flip on the TV, you'll see us talking and showing you different things than what you're used to looking at with the reflectivity. We'll show you the velocity mode, because if something is moving, if you're right here and something's moving towards you and then all of a sudden it's moving away from you, what does that do? It starts spinning, right? And there's a little demonstration over there of a tornado coming down. Have you guys seen it? Right? With the water vapor, you can see the, okay, that's the theory behind rotating storms. And when we as meteorologists see storms rotating, sometimes that rotation is aloft because the radar beam is shooting up and it's seeing that spinning. But the key is that going to be pulled down to the ground? And obviously if it is, then you're talking about a tornado. So there's all sorts of different things we can look at with the radar, but you can thank Christian Doppler for that piece of it. But this is simply just the reflectivity that we're looking at here.
So one other thing you mentioned in that video really quick, there was a buoy that had a lot of information. Sometimes when you see the weather with all the temperatures, there's a temperature out in the middle of the ocean. If you really want to know what the weather's going to be in Boston, why do we care what the temperature is out in the middle of nowhere?
Right, because, you know, if you have fish for friends, you want to be able to inform them what the water temperature is, right? No, that makes no sense. So the water temperature is really important. Who remembers last winter? Who remembers Christmas last winter? Who remembers how warm it was last winter? Yes, all right. Well, a lot of that had to do with the water temperatures. And not just the water temperatures here, but the water temperatures in the equatorial region of the Pacific Ocean off the coast of South America. Because that basin of water was really, really warm. And when it gets really, really warm, it can alter weather patterns globally. And that's what happened last year. We have a name for that particular region of the ocean and the water differentiation there, and that is called El Nino. Have you heard of El Nino? Yeah. So last year was the strongest El Nino on record, one of the top 2, 3 different times throughout the several-month-long period it existed. But they've been keeping track of those measurements since the 1950s. And since the 1950s, every single time there's been a really strong El Nino, the winters in the Boston area have been minus. Last year was one of the reasons for that. So when we look at ocean water temperatures, you know, the air and the ocean, they're all part of a system that work together. Because the weather just doesn't happen over the land, right? It happens over the ocean. So it's just as important to know the temperature of the ocean, because the air above the ocean is being impacted by that. So it's very important in all of our global models to know the temperature of the ocean. Okay, so that's the forecasting side of it. But also, too, if we've got a nor'easter coming, and we're going to have a northeasterly wind, because that's what it means, okay? And the water temperature, you know, is 40-something degrees. Do you think we're going to be able to hang on to snow in Boston? No. It might start snowing, and then it's going to change over to rain. So that's really important for us to know, to keep track of when we're putting our forecast together. We're trying to figure out that rain-snow line and how strong that wind is going to be off that raw water and how far, west it's going to be pushing back. Is it going to, be a changeover line to 128, to 495? Where is it going to be? So the water temperature is really important for many reasons, and those are just a couple.
Alright, so our last video is making a prediction, taking all that, putting it together, and trying to say what the weather is going to do next.
Now that we've got a handle of what the atmosphere is doing right now, we're ready to predict what it will do in the future. This is called a forecast. Now we make forecasts from a few hours all the way out to 7 days into the future. Technology has improved a lot over the years. It has advanced so that what is forecasting today is largely based on what's called computer models. These rely on complex math equations that mimic the way the atmosphere behaves. They take in all the observations of the current state of the atmosphere and calculate how different parameters will change from hours to days out into the future. It would take a person days to solve those math equations, but high-powered supercomputers can do more than 1,000 trillion calculations a second. Now, there are many models to look at, and they update multiple times a day. Meteorologists learn how to analyze and interpret these weather models to guide us in making our forecasts every day.
So you've got all those observations going into the computers, looking at the models, updating it several times a day. For the weather here in New England, which is some of the most unique in the world, how big of a team do you have to put all that together for you?
Well, there are, as you saw in the video, there's 4 of us there. Danielle's no longer with us. Danielle was at the beginning. Danielle's now working as a meteorologist in Nashville. She got married in June. She's doing wonderful. And we have a new member of our team named Kellyanne, who just started a couple weeks ago. She went to Rutgers. She's from the Northeast, and she had been working in West Virginia, so she's really excited to be here. She's not a New England sports fan, though. So I'm gonna work with her and see if we can change that. It's very disturbing. It's okay. She's from New Jersey, so we'll fix her up. It'll be fine. But so there are a lot of us, but we all have different times of day that we're covering what's going on with the weather. So when I get there at 1:45 in the morning, well, I actually get up at 1:45. I get to work about 2:30. But when I get there, there's nobody there but me. So I'm kind of doing everything on my own. But when there's a big storm coming, we're absolutely working together. I feel so blessed to be working with Harvey Leonard. He is amazing. He's a gorgeous and a great teacher. And when there is something coming, we're chatting all the time, texting, talking, looking at models together. The biggest challenge for me is we're on the air at 4:30. I mean, you just saw in this video a couple of frames of models. I mean, these models, there's so many of them. They're updating all the time. You could just spend hours and hours and hours and hours looking at things. You just kind of have to cut yourself off. And it's not something where I just am paying attention to the weather when I get there and I stop paying attention when I leave. I'm absolutely all the time, to the point where my husband just gets frustrated. I'm very much in tune with what's happening with the weather. So for me, I've been doing this almost 22 years. The evolution of what is available to you to look at, to forecast, has changed so much. I can't even imagine where it's going in the future. And probably biggest evidence to you, if you watch before a storm is coming, we'll show you different models. Well, the Euro model is saying this, and the GFS, or the American model, is saying this. And when tropical system is coming, we show you the spaghetti charts with all the different squiggly lines. There's so many of them, right? Those are all models that we could sit there and look at and analyze. So it becomes very important to begin to recognize patterns and know the biases of different models and when they perform well and when they don't, and how a model has been performing to know whether or not you should trust it. So you can watch different forecasts on television, and each meteorologist is looking at the same data. We may interpret that data differently and create our own forecasts, but we're all looking at the same data. So it's kind of like if you're here at the museum and you're looking at a picture or painting on the wall, it's like, okay, you're all seeing the same thing, but then if you were asked to explain it or describe it, you might each see something different in it and describe it differently. So that's kind of what we do. And so it's great when you can work with your colleagues and come up with a forecast together, but on a daily basis, I'm kind of flying solo.
All right, so we have time for just a couple questions. Does anybody have a question for Cindy?
When I was growing up on TV, the women were weather girls. And I'm wondering how it's been for you to kind of break through those stereotypes. And obviously you're very well educated. Now you have to have a degree. You're actually a meteorologist. So what has that been like as a woman, because most of the meteorologists traditionally were men?
They were, but that is so past tense now, which is great. There are actually sometimes just as many women now as there are men on a team, which is amazing. And when I first started out, women were kind of a new thing, and it's like, okay, we've got one, we're good. Phew, we've got our quota, we're good. We don't need another one, we've got one. So there's more and more now. So for me, when I started studying meteorology, in my very first meteorology course, my introduction to meteorology, I went to a tiny school in Vermont called Linden State College. Tiny little school, has an excellent meteorology program, a great communications program, and not much else. It's a tiny school in the middle of nowhere, but growing up in Maine, it appealed to me being a small school. I remember I was very shy when I was younger. So in that first class, there were 80, I think 3 males, 2 females. And 4 years later, who actually graduated with a BS in meteorology, there were 6 males and 2 females. Yeah. There are some of us that took a little longer than 4 years, or changed majors or things like that. But it's a hard program. I mean, it's a lot of physics and calculus. It's very science-based, and a lot of people are interested in weather, but don't realize all that's behind it and that goes into it. But now there are more and more women that are interested in getting educated and getting degrees and pursuing that. So definitely more visible on television, but there are so many meteorologists that are not on television. One of my favorite stories to tell is someone I went to school with started his own company. It's a consulting business where he does forecasts for companies that have to ship things across the world because they, load up their ships and they don't want to send them out into storms, and they have very sensitive things like coffee beans that, will be affected by different temperature changes and moisture and things like that. So something so obscure that you never think about, it's his whole life for 20-something years. So there are meteorologists with the aviation industry, when you're flying. I mean, there are so many different things you can do with a degree in meteorology besides being on television, but I think that's probably the most visible way that when you think of a meteorologist, that's what you think of. Yeah.
All right, we have one more question.
What was the worst storm that you've seen, and when did it happen?
When did it happen? The worst storm that I've seen. Okay, so let me tell you a little bit about where I've been, because I grew up in Maine and I went to school in Vermont, right? But I got my very first job as a meteorologist forecasting the weather on television in Bismarck, North Dakota. Has anybody ever been? Yay, all right. Not a particularly, spot that people seek out to go visit, but it's a lovely place and great people. So there were some pretty wild storms there. But my second job was in Plattsburgh, New York, Burlington, Vermont. It's a market that is a really interesting place to forecast as a meteorologist. It covers a huge area with the Adirondack Mountains on one side, then the Champlain Valley of Lake Champlain, then the Green Mountains on the other side, and then another valley. So it was a very challenging place to forecast. And oh, by the way, whenever you have northwest flow, you're getting very limited data from the data hole known as Canada. Okay, there's a lot more data coming from there now than there was in 1996. So it was a challenging place to forecast. And while I was there in January of 1998, there was a historic storm. It was called the Great Ice Storm of 1998. Okay, and when you think of an ice storm, what do you think an ice storm is? Do you think it's ice falling from the sky, a storm of ice?
No.
Maybe what? Hail? That would be logical, right? Well, an ice storm is actually a rainstorm that freezes, okay? Let me tell you a little bit about the journey of a snow.
Layer of warm air, so it melts, okay? And once you've been melted, you can never turn back into a snowflake. So, in the summertime, usually once a snowflake melts, we get rain. But we're getting into that time of year in the month of November, December, January, February, March, April, and sometimes May and June, around here anyway, that you're not always going to get rain. You're going to get other types of precipitation. And if it's cold from where the cloud is all the way down to the ground, that snowflake falls as a snowflake, right? Makes sense. But sometimes there's different layers and different temperatures in the air between the cloud and the ground. And that's what meteorologists spend most of our time trying to figure out, okay? And we do that with weather balloons. But anyway, so say the snowflake melts, okay? And then it runs into a layer of cold air again. It can't turn back into a snowflake. It's got one chance to be a snowflake, okay? So instead it refreezes into a little ball of ice. That's actually called sleet. Not hail, but sleet, okay? And then sometimes that can fall all the way down to the ground. What happens in an ice storm, it's actually freezing rain. Have you ever poured water into your freezer?
Yeah.
Yeah? So what happens to it? What does it do? Turns into a layer of what? Ice. That's what freezing rain is, okay? So a snowflake runs into some warm air and it melts, and it might stay warm all the way down, down, down until it gets to like the level of the treetops and the power lines, okay? And those surfaces might be really cold. So that rain will hit that cold surface, and then when it makes contact with that cold surface, it freezes. So that's why sometimes it's raining, and you go to take a step on the driveway, woo, and it's really slippery. That's ice. And if you get freezing rain to happen for hour after hour and day after day, it creates this layer of ice that gets heavier and heavier, and it weighs down the trees and the power lines. And in 1998, that happened. And it happened across a huge portion of Canada, and northern New York, and northern Vermont, and northern New Hampshire, and a good portion of northern Maine. And it lasted for days. And there was basically a stalled front with waves of moisture. The temperatures didn't change in the atmosphere until day 3. Then it got really warm, and it got to like the 60s, and there were thunderstorms. So then it rained more, and a lot of the ice melted. Then it got cold again, and everything froze. It was a disaster of epic proportions. You can still drive through the Adirondack Thruway, and you can see where the temperature inversion was. You can see where the trees snapped and where they didn't. It's pretty amazing. But for me personally, being part of that storm was probably the worst storm I had ever experienced. Because I had a dog at the time who we had brought to the vet to have a little procedure. And I didn't see her for 2 weeks. She was there for 2 weeks. We had the National Guard in the streets, couldn't get out of my driveway, everything was blocked. It was pretty amazing. And it was unfortunate too, because it got so cold behind it and there was no power. They ran out of generators, and there were a lot of shelters and things like that. But I've seen a lot of storms. Just the winter 2 years ago, all of you in here, you're gonna get to tell your kids and your grandkids that I lived through the winter of 2015. Because it was amazing, right? That 6-week period, that is never going to happen again in our lifetime. Not that way. It'll snow, and it'll snow a lot. And you might have flashbacks, but it's never going to go down the way it did during that 6-week period. It just can't. I mean, it never happened before, it's never going to happen again. And what's interesting is that the drought that we are currently in started during that snow blitz. Makes no sense, except you remember how cold it was during that snow blitz? Remember how fluffy the snow was? We actually ended that winter with a deficit in precipitation. Despite the fact that we had crazy amounts of snow, when you melted it all down, the liquid equivalent was below average. And then each successive month through the rest of 2015 and all of 2016, except for 2 months, we've had below average precipitation. And October was the first month since February that we'd actually had a surplus of moisture. So it's kind of counterintuitive to think about that, but yeah.
All right, so if you have any more questions and you'll be here for a few more minutes, you can come on up and say hi. It's also our Women and Girls in STEM event today. It's starting at 1 o'clock, that's right now. So throughout the museum, there'll be women STEM professionals you can talk to about what their favorite subjects were, how they got into science, and you can really talk to them up close and personal. So once again, thank you, Cindy, for coming and joining us. Let's hear it for Cindy.
Thank you. And girls, don't be shy. If you want to come up and say hello, come say hello, okay?